playing with the woodworking again. I decided I wasn't happy with how these side pieces came out. My jointing technique with the sort of biscuit in the middle works fine. That's very, very strong. That would not go anywhere. But I discovered that trying to do it in one piece like this, even a tiny little bit of misalignment means when I try to put this back on the car, things weren't really lining up that well. I could have forced it, there's enough spring in the wood, but I wasn't happy with doing it that way, so I figured I'd have another go. It's only wood, I can always get more if I need to. So I've been looking at it again, trying to figure out how to do it to make it easier to get everything to line up and make sure all of the screwed joints are nice and strong and I don't have screws going into end grain and things like that. So I checked back with some original bodies, and this front one is actually joined like this. I was going to join it to the face of the timber, but it's actually joined underneath, which also then means that the top of the door opening is one continuous piece, which makes sense. So I trimmed this down because I had to lift it up a bit, and I've cut these pieces to be the exact height for the door opening, and I've sort of just clamped it all up. That's all reasonably solid now, and I was able to trace out on this where I need to cut it to make that work. The other thing I didn't like about these ones is I made them a bit too narrow, so I wasn't getting full contact across here, and you have to think, well, this gets sort of planed off on the bottom edge and it's got a curve on this edge, so you want to maximize the amount of surface there where it's all glued, where the joint's made, and because this is kind of diagonal, you're cutting a slice across a diagonal, so if this didn't go all the way across, by the time you've taken those slices out, you've really reduced the surface area off the joint there. So what I was able to do is I actually, it's this one, this is the little piece I cut off, and I'm able to use that to transfer the curve around. So this is the curve that follows the body. I'm not convinced this curvature is correct, but I think it's just an optical illusion with the way it looks at the moment. But the door sits in here, so the door skin sort of starts from here and curves around, and the door does have a lot of curve in it, but it just looks a bit strange to me. So I'm going to leave everything a little bit fat, and then I'll plane it down or sand it down to fit. But the idea is I've marked this up. My template is still correct, which is this. That's the other thing I found, is I'm not sure I made sure the ends of this were completely parallel before I used it to mark out these pieces, because when I had these clamped in place, the two ends weren't parallel with each other. So by doing it this way, I eliminate that. And I think it's also better to screw everything together so it's not under any sort of tension at all. You're not forcing anything into where it needs to be. So this shape, that shape, by the way, matches the door. So you can see this line of the door. This door skin is a bit battered, but you get the general idea. That's not a straight line, it's got a curvature to it. So this curvature has to meet the top of the door. So if I'm using this to cut out the frame, the door sits underneath it. So those two have to sort of line up, which they do. Obviously I'm not using that door skin, so I do get to tweak that a little bit. I'll basically make the door frame to fit the body and then make the skin to fit the frame. So this should hopefully be close enough. So what I'm going to do is trim this here, and I've marked around the edges because obviously I have to trim this and have it on that curve. So that's what I'll do next. When the screws arrive, I can just screw all of this together as it is. This piece here, again, I've cut the ends square because that's the easiest way for me to make a nice strong joint, but this is fractionally higher than that. So the way it's sitting at the moment isn't correct. It's because I've got it clamped to the stick. But if this is square and this end is high, you'll end up with a little gap here. So what I'll do is I'll screw this onto this piece and it'll be sitting a bit high here, but it all needs to be planed down anyway. So that's how I'm going to do that bit. For the door pillars, I may do the same sort of joint that I did there, but that means routing the pieces of timber and things like that. I think it would actually be strong enough if that is just like a butt joint, and it's screwed all the way down. But then the problem then is, because the grain's going this way, you end up screwing sort of into the end grain. So what I might end up doing is remake these pieces, which I have to do anyway, and arrange it so the grain here actually join two pieces together, so I can control the direction of the grain. So it's straight here and more on an angle here, so when I screw down into it, I'm not just screwing straight into the end grain part. I think that's probably what I'll do there. These are the templates, and technically these are each slightly different because they're at slightly different positions along the body, but if you overlap them, the difference is so minimal. We're talking sort of millimeters. They're almost exactly the same, just because of the nature of the curve of the thing. So that's my thinking for that. I think this will be a much neater way to do it. I did mess up a little bit, and when I cut these new bits of board, I actually cut them too short. I forgot to add on the extra width there. So I am one board less than I had before, but that's okay. There's going to be enough little bits and pieces I need to make that I'll end up using all of that anyway, I think. So yeah, at the moment it's just a matter of me checking and rechecking and double checking everything, just to make sure I get it absolutely correct. But I think this is a better approach. We'll see. The door pillars, or where the door hinges go on these, it all gets reinforced with metal brackets as well. The other thing I'm going to do is I'm going to modify that end to get more contact there. So I'll make that go across the whole width of that board, whatever that ends up being. I have to keep reminding myself that even though I made all these templates in CAD, I don't have to use them exactly as they are. I can modify them as I go. I'm not welded to the model necessarily. So I'm probably just going to sit and stare at it and measure it a few more times and work out exactly how I'm going to do it. But as I say, I think this is a much neater way to do it. I've roughly trimmed these door top rails now. Obviously this would all still need planing off to get it to follow the curve of the body, but I think that's going to work a lot better. Everything's just sitting where it needs to be, nothing's under tension, and I should be able to screw everything together. So I can put screws in from underneath there, screws in from the end, and that should all work fine. What I'm discovering is I did remake one of these side pieces. This is what the door hinges go on, and on this one I modified the top to make it thicker. I realized you're going to be screwing into end grain no matter how you do it, unless you run the grain the other way on this, and you don't want to do that. But what I'm discovering is, between my CAD drawing and real life, I can't use the drawing for the direct templates of some of these parts, because the way they fit together means if I'm a few millimeters out, it all goes wonky. So that's what I found when I was cutting this one, for example. So if that goes in square, the curve's too much. It doesn't fit in properly. So if that's in there, it sticks out too much at the bottom. And like I say, it only takes a small offset in the measurements and everything goes out of whack a little bit. It's pretty close. And I did deliberately make this slightly big at the top. So the idea is get this piece fixed in place and then make this fit. This one, it's actually not as far off as I thought it was. Again, here you see the problem. Until everything's secure, you can't really push things into place. Everything else moves. But a better way to do this may be kind of how I did this piece, and just keep it all completely square, cut the end square so it fits the gap, and then I can still use my model to get the outline that I need, and then just trace that on the outside. The inside can obviously be whatever shape it needs to be, because that doesn't really affect anything. You just want it to be out of the way. So that is probably how I'm going to end up doing that. I think that'll give me a much better fit. And regarding the screwing into the end grain, I think I'm overthinking that, because that's how they built them. That's how they were built, looking at the pictures. And again, they just rely on all the steel bracketry to help hold everything in place. So there's brackets at the bottom and brackets at the top. I did wonder about drilling through, and so instead of just screws, putting some wooden dowels or something like that in there, but again, that might be overdoing things. The other thing I did is I had a go at bashing one of my joints with a hammer just to see what would break first, and the glue doesn't break, the wood breaks around it. So interestingly, this one split on the end, split on the wood. So cutting the slot in it like that makes the wood weaker, because you've made it narrower. So if the glue is strong enough to hold by itself without coming apart, then I'm probably better to leave it solid like that. Again, it's interesting trying to figure out the best way to do all of this. The other thing you have to consider as well, of course, is this thing isn't all just flapping around in the breeze. It's going to have a skin over it. So the skin gets wrapped around the timbers, and that's going to also help hold everything in place. So again, I think just copy how they did it from the factory. They probably knew what they were doing, I guess, and you know, there are still original cars around that are 80 years old. They may have had some work over the years, but I'm not going to be worried if this doesn't last 80 years. So that's where I'm at the moment. I think now I'm at the point where I'm waiting for screws again. Hopefully they'll get delivered in the next few days. Not too much to talk about on the car frame this weekend, because I'm still waiting for some screws to arrive. And then I can actually start screwing some of this together. You can see how I've cut out the parts roughly, and I've got lines that I need to plane everything to, but I'm going to keep it. I think I can do that on the actual frame. I think that'll be a much easier way to do it, because I realized trying to do everything with patterns, it actually makes it quite hard to get everything to line up. So this was one of the side pieces I made, and it's quite hard to get the ends parallel. So this will eventually fit in there like that, but you kind of have to get both ends parallel and get it in the right position, and you can see it's not quite right. So what I can do is, of course, I can sand the ends, but you've only got so much you can sand because you sand too much and then the piece is too short. So I'm thinking a better way to do this is to not cut out the shape first, but just keep it as a flat piece of board, because I can easily cut the ends parallel and get the length exact, slide that in, and then I will use my paper templates. I'll transfer that to a piece of cardboard so I can get this outside shape, but I can actually mark it on the car. I think that's going to be the better way to do it. This bottom corner is correct, so this line is correct. So I'll be able to make a line from there to the outside of the bottom frame rail, and then it'll be exactly right. So I'm finding the limits of my woodworking, and it doesn't take much to be off. So if you were doing this in steel, you'd be welding bits of steel together, and if you weld a piece of steel on the bottom frame there, I can probably show it on my Austin. So the Austin 7's all steel tube frame. So you can see how it's all just brazed together. So if you have a piece there, or if you're brazing in one of these side pieces and it doesn't quite fit, it's metal, so you can whack it with a hammer and it'll bend and it'll change direction. That doesn't seem to work with wood. So it's kind of interesting learning how to work with a new material like that and learning what your limitations are. So that's what I'm going to do. I'm going to make it as easy for myself to get it accurate as possible. Probably means I'm going to waste some timber, but I'd rather waste timber and get it right than try and do it and have things not line up quite correctly. So that's where I'm at on that. Because I haven't been able to do that, I've been doing a few other little jobs. That's actually for the little bike, for the KT250 over there. I should probably do a whole different set of films for that. But I tried to beat out as best I can all the dents. Somebody had caved all of this in to fit a different seat, and I had a heck of a job trying to beat that out. There are creases in there, and unless I took the whole thing apart, I couldn't get those out fully. I sort of did the best I could. It's just a sort of beat up ride around the garden bike anyway. Same with here, these dents, I pulled them out as much as I could, but there's still dents there. But I'm just going to repaint it and put some filler over it probably. This is the tool I made to actually help beat out those dents. So I ended up drilling a big hole in the bottom and poking that through and trying to hit against that. And then there were pinholes all through the bottom of the tank. It had rusted through. So I ended up welding over it, TIG brazed over most of that. And then I've used this red coat lining on the inside. It's this stuff. I know other people recommend POR 15. I've used that before. And if it works well. But I never quite trust it. And if it goes wrong, you're screwed, because it'll just peel off in sheets. And if it's inside a tank, you've got no way of removing it. Whereas this red coat stuff, it forms a sort of rubbery coating on the inside that's fuel proof and ethanol proof. The only thing that seems to dissolve it is acetone. But the good thing is, if you screw it up on a tank like this, you just fill the tank with acetone and it dissolves the stuff out. So I prefer using that. I used it on my Austin 7 fuel tank that I made, and it worked fine in there. It's holding fuel. Well, as far as I know, it's holding fuel. I haven't seen any leaks. So that was the bike. Then I've been trying to do some 3D printing this weekend. It's been ages since I've done any. Actually for my Enigma machine, but it's one of those weekends where it just hasn't gone right. Messing around with it, it's just not printing well at the moment. I need to have a look at the machine, give it a good clean, strip it all down probably. But I did go back to this, which is my Rotax switch panel, because I did already have some of these printed out. I ended up printing these out in ABS and just sanding it, sort of polishing it a bit. And the switch here is a modern rotary switch. what I will end up doing in the car is I will have hidden relays that this is switching to. So this is for the charge settings and the lights, basically. The starter switch, I have a remotely mountable starter solenoid, so it only needs a low current 12 volt signal to get it to switch. And I've been trying to figure out the best way to do that. And I came up with these. So these are micro switches. These are just from RS. And you can see it's a standard micro switch with a little plastic plunger and this metal frame, threaded frame that goes on the outside. They're riveted in place, but that's easy enough to remove. So I ended up taking one of those, stripping it down. This is the little plunger that goes inside there. And I made a new plunger out of brass. Just machine that up. You can only just see it. The little flats on the side of the plunger are just to clear the bracket when you assemble it. That's why there's a big cutout on the side here, but you need to turn it round so it'll actually slide past the little bracket. So I just filed a flat on there. And the other thing I did on mine is I drilled a small hole in the end of it, and there's an extra spring in there, and that just stops it rattling around. So this one doesn't really rattle because it's plastic, but these little micro switches, they sometimes have different heights of the actual switch contact. So I put that little spring in there. I'm not sure if you can see it, just to give it a little bit extra resistance on the starter switch. I need to put a little bit of grease or something on there. The fuse is just a fake. I need to reprint that, make a nicer version of that, but that's just a fake fuse that's stuck in there. So that came out okay. I was also playing around with my little laser cutter and seeing if I could either use paint on top of aluminium, kind of as a resist. What you do is you spray the aluminium with a layer of black paint, and then using a laser you can etch away where you want the letters to be, and then you acid etch, or rather you use a base solution for aluminium, and you can etch away where the mask's been removed. The problem is my laser is only a little diode laser. I can mark the paint, but it's not powerful enough to actually burn all the way through. The other thing I tried is using masking tape, and that works fine. I've used it for bigger things as a stencil, but this is just far too fine. It doesn't really work with that. So that didn't work. The other thing I should maybe look at is if I could get this printed in actual metal, but I think in New Zealand that's just far too expensive. I need to see if I can figure out how much that would actually cost. But this has come out okay, it looks fine. You have to remember that once that, whoop, the gimbal's going to work, in the actual car, the instrument panel's down here, that's hidden down under there anyway. So the instrument panel's in about there. You can barely see it, there's only just room for it really. So that'll go in there. So I think that's good. I might keep working on trying to make better and better versions of those, but that one seems to have come out pretty well. So it's kind of where I'm at the moment. Actually, I completely forgot there was something else I got done. Thought that didn't seem like much for a weekend's work. The lamps, I'd put those aside for now because I had the issue that the little bulb holders, the replacement ones, are smaller diameter than the holes in the shells and also in the back of the reflector. That's kind of there. So the way I solved that, I think I talked about using heat shrink or something, which was a daft idea, somebody pointed out to me, because the shell is one side of the electrical connection, so obviously you need something that conducts. What I ended up doing was buying a piece of brass tubing I actually had to get this off AliExpress because I couldn't find anywhere in New Zealand where I could just get a nice small piece of reasonably thick wall brass tubing. I know model shops and places like that have it, but not up to this size. And to be honest, the model shops in New Zealand don't have much selection. There are specialist metal suppliers, of course, but it actually ended up just being cheaper to get it from China on AliExpress. So I ordered that, and I machined down some little, I guess you'd call them collars, split collars. So these are just 1/2 inch long brass, and then I put them in the mill and machined a slot out of them. It ended up being about a 5mm slot, and that gives me a collapsible little brass collar that's the perfect fit inside there. And then these are a good fit into those, so that all slides together nicely. The reason there's a socket here is because there were cables, so you can actually remove the headlights, they just unplug. So that was, there we go, that was another little job, which means now I could actually rebuild these if I want to, and I think I probably will, and I may just leave them how they are for now. The surrounds, of course, I would have to get those replated. That's not going to be cheap, and then of course they end up looking far too brand new probably. So I think what I'm going to do is just reassemble them as they are. Eventually these would be painted body color, whatever that's going to be, but the rest of it I should be able to assemble. These are the LED bulbs I got, so there are chips on either side, and that's how you get the dip, the high beam and the low beam. I think in high beam both of them come on, and in the low beam just the lower half come on. So they should work fairly well, I hope.